All right, this is kind of where we put all the logs together. So hopefully the lessons so far have kind of made sense. We've gone over some of the rules of logs, the fact that a log is the inverse of an exponential equation, but the answer to a log is an exponent. Okay, and so hopefully this has been okay so far. We're now going to use those bits of knowledge to try to solve log questions. So this is kind of the culmination of it, being able to solve a log equation. All right, and I couldn't help but think this is probably an appropriate meme here. Well, hopefully that's not you, because you're going to do great in this next lesson. So let's take a look at log equations. What I've done is I've broken them into three types. And I think this is actually a helpful way to try to solve these. If you can recognize what type of equation it is, then it kind of gives you steps that you should follow. You know, when you look at algebra, you've been doing algebra now since probably grade 7. Most of you, when you see an algebra question, you right away recognize what you're supposed to do. You go, I've seen one like this, I should do this first, or I should do this first. I hope logs will turn into that kind of a situation. So the first type is if there are logs, in other words, the word log, and it's only on one side of the equation. So take a look at this example here. Do you see how there is logs on this side and no logs on the other side? Okay, so this is a type 1 question. When you have type 1, what you're going to do is you're going to condense the logs. This is using the log laws. Okay? And then this is always going to be your step when there's logs on one side. You're going to change to exponential form and then solve. Okay? And then we'll talk about this a little bit later. You have to check. So let's take a look at this one. I'm going to condense this into one log. So I'll have log base 3. And what is my rule when I'm adding two logs? I can condense them into one by multiplying. So I have 9x times x. This would be 9x squared. Okay, so that's step 1. I've condensed the logs. What I want to do now is change to exponential form. So this means 3 to what power is 9x squared? Okay, so I'm going to write 3 to the power 4 is 9x squared. And now it's an exponential equation. We want to solve this. So 3 to the power 4, well, 3 times 3 is 9 times 3 is, so this is 81. If I divide both sides by 9, I get 9. And then what is x? It's plus or minus 3, because the root of 9 is 3. Okay, so what I'm going to do is I'm going to write my answers like this. And I'm writing them separately because now what I have to do is go check. Okay, are these both okay? Well, how would I check? What am I doing? I don't expect you to have to write this out, but what you're doing is you're saying, if I put those values back into the equation, is this okay? 9 times 3 plus log. I'm not even checking to see if it actually equals 4. I'm seeing if this is okay to do. Well, can I figure out log base 3, 27? Yeah, 3 to what power is 27? 3. Can I figure out log 3 base 3? 3 to what power is 3? Yeah, it's 1. This is okay. But look what happens if I put in the negative 3. Okay, if I put negative 3 here and negative 3 here. In fact, I'm only going to look at this one. Okay, what value? 3 to what power gives you negative 3? Can you do this? Well, you can't. There is no value of x that's ever going to turn a positive number into a negative number. And if you remember our rules about logs, all right, we had some rules about what this had to be. This has to be greater than 0. So that's what you're looking for. You're looking for making sure this value is greater than 0. Okay? So, having said that, we now have to cancel that answer out. Okay, so let's try another one. Here again, we have logs on one side of the equation, so let's condense them. log base 2, and then I'll have x plus 2 times x. Okay, now I can change to exponential form. 2 to the power of 3 is, and then if I multiply this, I get x squared plus 2x. So bringing the 0 over, I get x squared plus 2x. Sorry, not bringing the 0 over, bringing the 8 over. And this factors x plus 4, x minus 2. So x is negative 4 and 2. A quick visual check. Is it okay if I put in a negative 4 here? No, because you can't have this. This is no good. Okay, is 2 okay? Yeah, 2's okay. Now, just a quick bit of advice here. Don't just look for the negative numbers here. Okay, it's not necessarily the negative numbers. For example, if our equation was log and you had 2 minus x, here you would actually be looking for what positive numbers don't work. Like here, for example, 4 wouldn't work, but negative 4 would be okay. Okay, so actually check, don't just assume it's negative numbers don't work. Check in the equation. Alright, now, type 2. Logs on both sides of the equation. Okay, steps are similar. We're going to condense the logs first. Then you're going to equate the numbers. I'll show you what that means. And then we'll solve. Okay? So, you know, if you saw this question on a test, you would recognize, hey, wait, this one has logs on both sides. Alright, so your first step is going to be to condense the logs. So you'd have x plus 6, x minus 1. By the way, what's the base of this log? It's not there, so that must mean it's a 10. Okay, so now we've condensed the logs, but instead of changing to exponential form, what we're going to do is we're going to say these two things are equal. Now here's why. Log of something equals log of something. Those two somethings must be the same. Okay, otherwise this could not be equal. Okay, so that's our principle here. So we'll now say that the two arguments are equal. Alright. And I'll multiply this. Okay, and now I'll bring everything to one side of the equation. So you get minus x minus 6. And then if I factor, I get two answers again. 3 and negative 2. Are they both okay? Well, take a look at 3, take a look at negative 2. Will either of them give me a negative value for that value of b? Okay? Doesn't look like this one will work. Alright, one more type 2. Let's condense these. Okay, and if I have a subtraction, that means I'm going to turn this to divide. Alright, and now since they both are log 5, log base 5, I can make the two somethings equal each other. Okay, how do I solve this? Well, let's change it to fraction, cross multiply. You get 7x is x minus 18. So 6x is negative 18. X is negative 3. Is negative 3 okay? Is it okay if I put that here or here? Well, it's not. So we're going to cancel that out. What does that mean now? I've just canceled out the only answer I have. So this is no solution. Okay? So those are the first two types. We'll do type 3 now. Okay, and you're gonna have to get used to doing all three of these. You might want to take yourself kind of like the equivalent of 2 lessons to do this. So type 3 is when there are no logs in the equation. Well, why is this a log question? Well, you're actually going to use logs because these are ones where the bases cannot be made equal. Okay? So take a look at this. This is actually an exponential equation. We did this a few days ago. When we did ones like this, we tried to make the bases the same. You know, maybe we would make this 2 to the power 2, and then we would do the same to 12. We would do 2 to the power of something. The problem with this question is you can't make the bases the same. 12 and 4 can never be written as having the same base. So here's where logs come in. This is kind of like the big ticket for logs. This is why we want to have logs, because we can't solve this exponential equation the way we have in the past. Okay? So that's the third type. There's no logs, but you can't make the bases the same. So you're going to take the common log. Common log is base 10. Expand and solve. Okay? So let's do that to both of these. We're going to take log of 12, and we're going to take log of 4 to the power x. Now we're going to use your log laws, because the idea here is we want to get x by itself. So our log laws allow us to change this to x log 4. You now have x as multiplied times log 4. So to isolate for x, we can divide by log 4. And so that's how you solve for x with this one. So now you're going to grab your calculator. We're going to go log 4. Oh, sorry, not log 4. We'll go log 12 divided by log 4. And we'll go to 3 decimals like normal, so 792. Okay? Let's try the next one. Here again, these bases cannot be made the same, so we wouldn't be able to solve that. This is not type 1 or type 2 because there's no logs in the equation. So to solve this, you're going to take log of both sides. And the reason we do that is it allows us to take the exponent and move it to the coefficient. Okay, so you're going to have x plus 1. Notice I'm putting brackets there. And then x log 6. And hopefully you see we got a little problem here. There's x's on both sides of the equation. So what I'm going to have to do is bring both x's to one side before I can isolate them. Okay, and here is a common mistake. A minute ago I said, notice that I wrote brackets here. If you don't, what does this mean? This looks like x plus 1 times log of 3, but it's not. This log of 3 actually has to go into both of those terms. So I'm going to write that step first. And 1 times log of 3. Okay, so this is kind of like the expanding part. I now want to bring both terms with x to one side. So I'm going to have x log 6 minus x log 3. Okay, and I'm going to show you the little trick of how do I get x by itself when there are two x's. Well, what I want to do is factor out that x. If I factor out the x, I'm left with this. And now to get x by itself, that's what I'm going to divide by. Now you could type that into a calculator already and get yourself a number, but I don't want you to do that because that's going to round off too soon. Okay, so just keep working at it like this without actually using the calculator. To get the answer, I want you to be able to put this whole thing in the calculator. Okay, so remember that's going to be log 3 divided by, and then in brackets, log 6 minus log 3. Okay, so let's try that in your calculator. Might take you a couple of tries. Make sure you use brackets. And some of your calculators open brackets automatically. Make sure you're careful with those. You might have to do some closing of brackets. So this is 1.585. Okay? So if you didn't get that answer, a couple of suggestions. When you're typing this whole thing into the calculator, my calculator, the second I press log, it opens a bracket like that. So then when I put in a 6, if I don't close the bracket, what it actually is going to do, it's going to say, I'm putting all of this into the log. Okay? So what you have to try to do is make sure that anytime a bracket is opened, you have to close it. And then if you're going to put log, mine opens it again, you're going to have to close it. But you will have put a bracket here, so now you have to put a bracket there. Okay? Every open bracket has to have a closed bracket. If you're having trouble with that, make sure you bring it to our chat and we'll try to go over that. Okay? Let's try another one. So here is probably the most common mistake for solving these log equations. Okay? Most of you would look at this and go, okay, these bases can't be made the same, that's fine, and you're going to do log 36 equals log 3, and then you have 2 to the power x plus 1. And you do that. This is fine, this is correct. Okay? But your next step, you need to be careful with here. This log has this entire thing in its argument. And what do we do when you see a multiplication? You should have log 3 plus log 2 to the power x plus 1. Okay? That's a really, really common error. Now, I'm going to show you a little bit of a shortcut. This doesn't always work, but do you see in this case that we could simplify this by dividing both sides by 3? If you did that, you would end up with 12 and then just 2 to the power x plus 1. Now this is a little bit of an easier question because now when you just take the log, you don't have to worry about is there any operation in there. I can just see that there's one log on each side. Okay, these will give you the same answer. I think it's probably a little easier to work with a second one. Okay, so what I would do if I were you, I would try to do it like the first version, so like this one. Try to do that one up there to see if you can get the same answer. Okay, that would be a pretty good skill if you can do that. So this is x log 2 plus log 2. And so this is the term I want by itself, so I'm going to take log 2 and move it to the other side. And now if I divide both sides by log 2, you'll get this. Now when you put that in the calculator, be careful, you need brackets here. Okay, so let's try that. Log 12 minus log 2 divided by log 2. So 2.585. All right, we're going to stop there and pile on a little bit of homework for you. So there is page 413, numbers 1 to 11. There is page 422, numbers 3 to 13. And then there is a worksheet called Solving Using Logs. All right, that's on the My site. So if you could get to work on that, might take you a little bit to get that done.